Welcome to this next innovation series on the future of robotics and automation in advanced manufacturing. I'm Alex Estevez. I'm a venture partner with Excel, one of the storied venture capital funds in Silicon Valley and the world, with a great history of success, great fortune with innovative companies like Slack, Spotify, Qualtrics, CrowdStrike, Flipkart in India, Atlassian in Australia. And I'm proud to call Greenville, South Carolina, my home. So today, what today is about is not just an awesome presentation demo from some of our nation's leaders in robotics, but more importantly, we're going to have a discussion from some of the top thought leaders in the field in the Upstate. And I'll introduce those leaders to you in just a moment. But as backdrop, it's an awesome thing to see these robots advance as they have. But really more importantly is how we talk about and think about the future of automation in advanced manufacturing in the Carolinas and the Upstate, and how more importantly, how we might benefit as a region. You know, we've got an awesome long history of embracing innovations in advanced manufacturing. It goes back over a century of this tradition, and this gives our region a competitive advantage. And if we play it right, we could really benefit from what many see as a major economic boon coming, given the waves of innovation hitting the industry. Before I proceed further, though, I would like to introduce John McDonough. John is the city manager of Greenville. He's our chief executive of this city, and John has been just instrumental to this broader initiative around innovation. And we're simply indebted to his encouragement and very thankful for his support. So let me hand it to John McDonough.
Great, Alex. Thank you so much for that introduction. Good afternoon, everyone. I'm John McDonough, as Alex said, and I have the pleasure to serve as Greenville City Manager. I want to thank you all for tuning in for today's Next Innovation Series. I'd like to share some background on today's conversation and where we are as we look at the future of economic development and innovation here in Greenville, especially the future of advanced manufacturing. Everybody knows Greenville and the Upstate have great strengths and assets to build on, and we have a tremendous quality of life, a strong university presence, an entrepreneurial support system in Next, and over 800 advanced manufacturing companies. We have a real opportunity here to chart our own course to leverage these assets, to create even more high-paying jobs and opportunities for individuals to thrive and companies to grow their business. Over the summer, I was part of a small group that talked about the future of economic development here in Greenville. We were very fortunate. We had a chance to speak with the CEOs of several major upstate manufacturing companies. Some of those included BMW, Michelin, Bosch, GE, and other key stakeholders to hear their thoughts and ideas on economic development. And in all those conversations, there's been a strong and recurring theme of advanced manufacturing as the historic backbone of the Upstate's economy. I'm excited to hear today's panelists speak on the future of robotics and automation in advanced manufacturing and how we can leverage those opportunities in Greenville to grow jobs in this sector. So thank you all for your participation. And Alex, I'll kick it back to you.
Thank you, John. We're again very thankful for your support and encouraged by your drive. So our panel of experts is comprised of 8 thought leaders in the Upstate. So before we go to the presentation demo, I would like to highlight and introduce each of these, the panel of experts. Let me start with BMW, Dr. Stefan Baginski, maybe a brief background of your role at BMW.
Yeah, so good afternoon, everybody. So Stefan Baginski, I'm with BMW for more than 20 years, and I've always worked in the automation field. So in particular in the body shop all around the globe. And in this field, actually, I was, during my course via BMW, responsible for a lot of developments in the automation standard. For example, what we use recently here on site is something we developed 6 years ago, which is now the basis for our global automation standard for all the body shops, which we're able to scale for small installations like a couple of 100 robots up to what we have right here in the Upstate now. And we're very proud about having this here with more than 2,600 robots in 4 body shops, operating that more or less 24/7. And we are very successful here. And actually, I think we in a position where we can really contribute to community here, but also to giving our ideas to even put or bring that forward into the next future. Thank you very much.
Thank you, Dr. Baginski. We're very pleased to have you, and your Terminator-like presence. You speak with authority, and we look forward to your insights today. Next up is Mike McCormick with Bosch Rexroth.
Yes, good afternoon. I'm now 33 years at Bosch. I had to do the math quickly just to clarify it. So I can give almost a historical perspective on factory automation back from those heady days when we thought all factories would be lights out with no people in them, to really where we are today, where people are still as important, maybe even more important than ever. And in my career, I've designed factory automation, installed factory automation. Now I'm responsible to run a production plant. So for me, it's more of a business perspective that I can bring. I think my colleagues are much better qualified to talk about the latest in robotics. I think I can contribute more on the business aspects of automation and how to grow and be successful in this market.
Mike, you've been very helpful so far. Thank you for your participation today. Matthew Cabe with Michelin.
Hi, good afternoon, everybody. My background is engineering at its core. I currently am the marketing director for our passenger and light truck business and the Michelin brand. But I spent the first majority of my career in machine development and really supporting our different manufacturing sites around the world, and even in some of our manufacturing sites as an engineering manager. But Michelin has been a part of the Upstate for over 50 years now. And we've seen a lot of evolution through that time as it comes to automation of factories. And as Mike said, a lot of discussions around lights out and things like that over the years. But I think I'm really excited to learn a bit more about how we can continue to advance our manufacturing facilities, specifically in the Upstate, where we have a very large presence.
We appreciate your presence, Matthew. And I'm especially excited to include your diversity of thought today in terms of your background. Brett Barron is GM for Advanced Manufacturing and Repair Technology teams at GE Gas Power. Brett?
Hey, how are you today?
Welcome.
Thank you. I've been with GE for a little over 22 years. And in this role, I lead a team that develops manufacturing processes for the latest generation of products that we're offering to the market. And in addition, we develop processes to be able to repair those engines as they're used throughout their life cycle. It's a global team. Our biggest development center is here in Greenville. And so, for me, I've been in engineering for just a short period of my career. I'm a degreed engineer, proudly, but the majority of my career has been in operations, both in new manufacture and services. And so, for us, it's really about, as we move to the future, integrating advanced manufacturing technologies, additive technologies, inspection technologies, and automation, and doing that at the right place and with the right level as we really push our company forward in terms of our lean agenda. In all my time with GE, lean is real here today, more than it's ever been. And, automation and control plays a huge role. But again, for us, it's not about automating every piece, every aspect. It's choosing the right tool for the right job. And look forward to learning a little more today. Thank you.
Brett, I think in part with your experience, this corporate industrial leadership group, the four of you represent almost 100 years of operating experience or manufacturing experience. So really fortunate to have that deep bench of expertise. That's the industrial corporate side of the group. The next group is advanced learning leadership, starting with Dr. Keith Miller, who's president of Greenville Tech.
Good afternoon. I am president of Greenville Technical College. I've been here for 13 years. And actually manufacturing, the manufacturing related programs were some of the initial programs at the college started when we opened our doors in 1962. But then due to the needs from a lot of the employers that you just met, changes in technology, et cetera, we needed to change how we delivered services. So we opened up the Center for Manufacturing Innovation in 2016, I believe it was. And we have a lot of industry partners there, a lot of original equipment manufacturers that put their equipment there. And we have a nice partnership with Clemson University. So the idea is, you might say, to provide that whole learning package, that whole experience from technician through the type of education that you would get at Clemson University on the engineering side of things. And looking forward to all the presentations today.
Thank you for joining us, Dr. Miller. I think your experience, particularly around continuous education and solving some of the labor gaps that exist in the current market, will be particularly insightful. So thank you for your leadership in the community and your presence today. In the same vein as Mark Johnson, who is the director of Clemson University Center for Advanced Manufacturing. Mark?
Yeah, thank you very much. And as you said, I'm Mark Johnson. I'm the director of the Center for Advanced Manufacturing here at Clemson and a professor in material science and engineering. I've been at Clemson about just coming up on 3 years now, 2.5 years, and really excited and really happy to be here in the Greenville area. My background, I've been an entrepreneur in my life, mainly in the semiconductor industry, been an academic, and I've been a government official. Worked for the Department of Energy for running their advanced manufacturing programs for a few years. One of the things I think, looking at the future of advanced manufacturing and robotics, in particular aspects of it here in the Greenville area, there's a lot of universities around the country where they get front pages of the New York Times about developing some sort of new robot, and they get all kinds of excitement about the future of it and very visionary on it. You think MIT, Carnegie Mellon, and Stanford on that. They're all about getting the serial number one of a robot in their community. What I think is fascinating, and this is why I came to Clemson in the Greenville area, this is about to getting to serial number 1,000 and getting return on invested capital from it. And I think that's where some of especially a lot of our faculty and researchers and students wind up working with the industries in the area, are what are the new challenges in solving that? And in solving that, that winds up driving economic growth in the long term. So I think this is the exciting part about what's happening here in Greenville. I will share, I've had a visitor from Germany over recently on their Industry 4.0 group, and they said, we wish we could do what you're doing here in Greenville. And so, I think more of this, more of the same.
Awesome. I especially appreciate the return on capital observation, Mark. But you're hitting all the notes. So really looking forward to your insights today. Now that's the advanced learning leadership team. And then finally, for our panel of experts, we have two innovators. Let me start with David Broomer, who is the founder of Weightless and has been a robotics advisor to DARPA, DOE. David, take it away.
Thanks. Well, I come to you with a background of a little over 20 years doing autonomous driving. And more recently, we've been doing some really exciting work with Clemson and IBM and the city of Greenville, T-Mobile, especially in bringing some of this into Greenville and really kind of demonstrating it. So on the CU ICAR campus, we have not only autonomous robots, and we're doing some autonomous driving with Honda and a variety of others, but we've sort of embedded this GNSS augmentation into the light post, which is really exciting. And so we have the ability, whether it's in one of your factories or on the roadway in the connected vehicle technology, a fully autonomous technology to enhance positioning. And we believe that this is an enabler, right? It's an enabler for smarter factories, for Industry 4.0, for autonomy and connected vehicles. So it's, in our mind, a really cross-cutting way to bring the era of GPS down to just a couple centimeters. And in doing so, you can enhance safety, you can bring more reliable autonomy to the table. So we see it as a way to increase the reliability of autonomy and hopefully get some real business benefit out of it. We're very excited to be working closely with John and many others, the city engineer there in Greenville, to actually begin applying this to parking and traffic control. So In our way of thinking, if you want smart robots, if you want smart cars, you need to also invest into a smart ecosystem. And we believe that Greenville can be sort of the epicenter for this smart ecosystem way of doing things.
Awesome. I think we all share that belief, and it's great to hear you expound it that way. Next and finally, but not last but not least, is Marty Osborne, who's president of Advoco.
Hey, Alex, thank you. And thanks everyone for being here. Marty Osborne, president of Advoco here at the Next Center. So we're part of the Next community. Advoco helps companies in the maintenance side of their equipment. So while I think a lot of you are in the manufacturing and the production of it, our goal is hopefully to help you keep those pieces of equipment up and running. So we believe that people can only achieve their goals if they have safe, reliable equipment. And, our goal is to help companies get greater uptime while at the same time reducing the cost of doing it. And automation has been great for manufacturing, but it has put a new burden on the enterprises for how they're going to continually maintain these pieces of equipment. And so we help companies in that area.
Marty, let me just put out a thanks to you for helping to also host this production. Your team, Mary and Josh, have been great, and I also really appreciate your perspective around uptime and the new importance of maintenance in this automated world. So this is an awesome panel of experts, and it represents the Upstate so well in terms of our potential and our stature and thought leadership. We have some outstanding national leaders that are joining us for the demo. So this is the part of the show when it's kind of like the science fair project where we all become kids again and enjoy what we're about to see on the advances in the technology. Before we go into that demo, let me introduce Bob Little, Kel Giron, and Milton Geary. Bob Little is the CEO of ATI Industrial Automation based in Apex, North Carolina. Bob, welcome to the show.
Thank you, Alex. And I'm trying to compete with the great customers here in longevity. I've been in a business and with ATI for 31 years, developing robotic tooling. And I have a degree in engineering, but I've been managing the company for quite a long time now. And of course, I'd love to get back into the trenches because we're developing some really fantastic product, and many of you here are our customers. And also, I've had the privilege of work with Milton Geary for the last 25 years as well. So between the two of us, we've seen quite a bit of advancements in robotics over the decades.
Well, let me use that as a segue to introduce Milton Geary, president for Shunk USA, based also in North Carolina. Milton?
Alex, thank you. It's really a pleasure to join this panel today. I'm blown away by all the years of experience. I was going to come up with, I've only been in the industry for a year or two, but Bob let that out of the bag. So I've been with Shunk for 20 years and I lead the team here. And we're also an innovator and component supplier to manufacturers in both the automation and machining world. As well, in addition to the work that I do here, I also serve as the president of the International Federation of Robotics, and I serve on the board of the Robotics Industry Association, along with Bob.
Guys, it's just a privilege to have you as a part of the mix. Thank you for your time and leadership today. Last but not least is Kel Giron. Kel is one of the founders of Ready Robotics, based in Columbus, Ohio. He's actually going to lead the demonstration. Kel, why don't you take it from here?
Awesome. Thank you so much for that introduction. And I'm so excited to be able to do this. So at Ready Robotics, we build software that makes the integration and deployment of robots easier. And we do that sort of by solving two key problems. One that was talked about, which is the fact that there is a very large skills gap out there. We can't find the people that we need in manufacturing to keep up with demand. And therefore, while education is super important, we also believe here at Ready that the technology needs to meet education halfway. And so the technology needs to be dramatically easier to use as well. The other thing that we build here is software, specifically our Forge operating system, which is designed to be a universal operating system for robots in a very real and commercialized way, similar to how Android and Windows are operating systems for those devices. And the reason for that is there's a huge amount of fragmentation in the industrial automation space. And we don't really have sort of a common tool set to use all of that technology. Whereas in the computer space, we don't think, give two thoughts to buying a laptop from one company or another company, or a mouse from a different company, right? It just all goes together and works because you have those common operating systems. So those are the problems that we're solving. And let me just pop over here to our demo, and I'll sort of illustrate how we do that. All right. So we have this industrial cell set up here, and you're in our Columbus, Ohio facility. This is a 60,000 square foot facility, and a lot of this space is actually dedicated towards doing software testing. Because we are building an operating system, we sort of have to build the software and then test it on the systems that are actually going to use it in the field. That's why we have a variety of robots here from a variety of brands. And that's really what this space is about. But in front of us, what I have is something that's a work cell that's very typical of a fully integrated industrial work cell. You've got a robot, various tooling, and the goal of this work cell is to tap these plates to put threaded holes in these holes that are already laser cut into this part. Very common task in industry, usually done by hand, but something that is easily automatable, and I'll talk about that. The other thing that we're looking at here is our Forge operating system, and that's really down here on this touchscreen. So we'll switch to that real quick, and I'll show you that this is really where the rubber meets the road when we talk about people interacting with robots, because the typical machine operator, someone who is actually doing the task, who would be tapping these parts in a factory, is has a very high level of expertise in their specific domain, right? They've been working there for 30 years. They know how to make these parts better than anyone else, but they may not be an expert at automation. They may not have never even seen a robot before, right? So how do we get robotics so that it is accessible to them? And this software, so this is the Task Canvas application, which is our very easy to use robot programming software running atop Forge OS, the operating system I mentioned. And the goal with Task Canvas is that we sort of take all of the different things that a system needs to be able to do, things that the robot can do, like move, stop, move along curved path, things that the grippers can do, like open and close, things that work holding can do, sensors, all of those different capabilities. And we turn those into these very easy to understand, human readable building blocks that say things like move and open gripper, right? They're designed so that they're accessible. This software runs on any of the robots that we support in Forge OS. So with this system here, we've got it on a universal robot UR10, but as you can see behind me, we've got a robot from KUKA, we've got a FANUC, a Yaskawa, an ABB, another KUKA. Just offhand, we've got, or off screen, we've got an Omron, an Epson, and a Nachi, right? So it's really any robot. And I'll talk about it a little bit more, but the user experience of using Forge to build out this task would not change if you switch to any of those different robots. So let's dig in a little bit to the cell here, because the other part of Forge, besides the robot programming, as I said, is all of the different devices that can be used with Forge. And that's where, that's what allows the robot to actually do the task. It's not just move around, but I have to lift objects. I have to sense that those objects are there. I need to have work holding. All those different components are also abstracted to these very human readable building blocks. So if we look at this work cell here, we've got a gripper by Schunk, a little 2-fingered gripper. We've got an ATI force sensor up here. This is their Omega 85. We've got a tapping arm from another partner of ours called FlexArm that makes these tapping arms. And then a variety of other sensors, pneumatic work holding, and other things that actually let this task operate. And I'll dig into task cams a little bit to show you how those devices are actually dealt with in our software. So if we switch back over to the software view, so you can see here, we've got a variety of different building blocks here. And what I did is I expanded one of these containers, and that's just a way to make the program a lot more readable and maintainable, because again, the person who programs this system may not be the person that's interacting with it every day. Someone who's a machine operator who really just needs to come over, be able to understand the basics of what's going on, and then put some parts here and press go. It really fits all of the different stakeholders that might need to touch this robot, from the programmer who's actually going to put it together, which often can be the operator themselves, all the way down to if you have someone who's really just coming by to press the button and refill the parts, right? So it fits all of those different users. So if we look at these building blocks, we actually can see some of the functionality we have. So this is a container that's designed to pick the parts from this stack here of parts. We first start by checking the sensor that is looking at the tap. Right here, we've got our tapping tool, and we don't want that to be broken. Taps break, it's a thing, right? But we want to make sure that that tap is unbroken before we proceed. So we have a block for that. We then have a move block for the robot to move to a position above the parts, a wait that the robot executes, and then a jog that moves down to actually contact the parts. When I come into contact with the parts, I want to pick one up. And so that's when we have a block here for actuating this shunt gripper. Again, I didn't have to write any of the code that talks to the pneumatics that actually makes that gripper open and close. It's really just this building block that does the magic, right? The other thing I want to talk about is in here, in this actual movement block, you can see we've got some parameters for how we want the robot to move. It's all very logically laid out, but we also have this button down here that says monitor force. And that's where the ATI force sensor comes in, because the goal of this is we want to move until we feel a part. We don't know how many parts are here, right? So we want to move until we feel the top of the stack, and then we want to grab that first part in the stack. And so we have this seamless integration with the ATI force sensor to be able to sense that force and then act on it. The way that we actually act on it is by the flow control of this program. And as you can see, this is a flow chart, which is a way that many people have learned how to represent tasks. It's something we learn about as kids. It's very commonly used in manufacturing. And because of that, it's very simple for an operator who has no robotics experience to understand the complexity of like a branching behavior, where if I am moving and I feel that there is a part there, I want to go and grab it. And so I go and transition over here to this block that actually grabs the part. If I don't feel any parts, well, that means that they might have exhausted them and that there's no parts left, and therefore I need to refill them. And so instead, the execution goes to this block here that pops up a message that says, hey, I need more parts, right? So with these tools, the simple building blocks that allow us to represent what the robot can do, but also all of the different things that all of the other components of the system, the hardware, the gripper, the force sensor, the work holding, all of that can do as these blocks, we can then tie those blocks together with this sort of simple bidirectional flow control from a flow chart. And when we do that, we're now able to build a program that is very complex, that does something as complex as this system does, but it's something that someone could learn how to do in days rather than months of training. I'll talk a little bit more about that, but let me reset this and we'll actually run this and you can see the robot operating. So we're just going to hit begin, and then the robot is going to go and do this task. Now I'll talk over the noise. There's going to be a little bit of noise when we start actually tapping, but the robot's going to first pick up a part, put that into an alignment fixture, and then put the part into work holding, and then use this tap here, which I'm just going to give a little bit of oil to actually tap the part. What's exciting about this system and the software is it really opens up the ability of people to use robots in very complex scenarios, right? We talk about the skills gap, but what we don't talk about is the fact that when I do deploy automation, I have to support that. We heard from the challenges of support, and who better to support your automation project than the people who are in your own factory, right? If you bring in an outsider because they are specifically trained in robotic automation, they're still on the hook. You have to bring them back if anything goes wrong or needs to be changed over, right? It's much lower cost to upskill your existing people to be able to use this technology. But what's critical is that the technology is easy enough that upskilling is rapid. And what we found is that with our software, learning the basics of using the robot and all of these different peripherals can be a matter of days to be proficient in actually building simple tasks. And then from an education standpoint, when we look at our education platform, we actually spend a lot more time learning about automation, learning about actually building this work cell rather than specifically learning how to program the robot. That's actually the smallest part of our training courses that we offer online. We have a course called Ready Academy that does this. So I'll actually stop it there because I want to be conscientious of time. But that's really the goal here at Ready, is to build technology that's really usable by everyone that is in manufacturing, and having a software that is scalable so that I can build an application like this and deploy it on any robot with any tooling I see fit. We see a lot of customers who maybe they buy a collaborative robot in the beginning. That's their initial foray into robotics. But then once they get involved, they're like, man, I need a bigger robot. I need to lift more. I need it to move faster. And they're kind of stuck because now they have to relearn all of this stuff over again. We can take this exact program and put it on any of the robots you see behind me, and we'd have to tweak some things because they're a different robot, but the program would be identical. And so now your staff is learning that one very easy to use software, and they can apply that in any context that your factory may choose to deploy its future automation projects. So it makes automation much more scalable. It makes your employees better utilized and more empowered, because now automation is a tool that they are invested in and empowered to use rather than sitting on the sidelines. So I hope you've enjoyed this demo. Happy to answer any questions about our software, this specific setup, anything at all. So thank you so much.
Great work, Kel. And for the broadcast audience, I would encourage you to reach into the chat function to connect with leaders from Ready Robotics or ATI or Shunk. I actually, before I go to the panel of experts, I would like to give the mic to Bob Little for any add-on color or observations.
Yes, Kel did a great job explaining the software. Let me tell you something that's coming down the road. The advancement of robotics is fostering the largest growth that we've ever seen in the history of automation. And it is going to be a tough road. We do not have enough workers to fulfill the manufacturing needs of this country. And that is not just true for the US, but it's true for many, many other countries. And we need to simplify what we do. And Ready has a solution that makes it easier to use the product. As simple as that. And you're going to have that because you won't be able to get all the technicians that you need. We're going to have to take many people that don't have the education that we think they should have. But if we have an easy enough use software like Ready, they'll be able to use the system. So as the years go down the road and robotics revolution takes off, the work that Ready's doing is going to be absolutely critical to ensure that we can all get access to the technology.
Beautifully said, Bob. I think that the need to simplify is it's astonishing how recurring that need is, but never so evident than today, it seems. I would like to pass it also to Milton before we go to the panel of experts.
So Kel, great demo. It really is impressive every time I see the software and how it's so impressive that you can be configuring an application as opposed to programming a robot. And that really is a leveler. And going kind of adding on what Bob said, we know what a skills gap looks like, and we also know how this affects us as companies. And when we look at that, we know what it takes to realize the potential that we'll have in the future as manufacturers, and also how we can compete not only as singular manufacturers but as a nation. And robotics and automation has a chance to bring us to that kind of competition. We know that this is a race. We know that China is putting in 4 times more robots than we are per year, and we have to ask why. We really have to ask why. And some of this is the hurdles, and lowering those hurdles to implementation. And again, being able to program the task or being able to configure the task as opposed to programming the robot. Very strong demo. Thank you.
Yeah, I think that the fact that it's a battle, it's a race right now, it's important to underscore that. And when you think about the future of the United States, a big part of that can happen here in the Carolinas in terms of how we can take some of these innovations and move it forward to improve our global competitiveness. I think it sounds like you have a question on the interaction with the PLC, but I'd love to hear your perspective as well on what you've seen today. How do you contrast that with your experience from when you started 20 years ago, or what's the biggest development that strikes you as important right now? Dr. Baginski.
Sorry.
Here we go.
Okay. So no, great presentation. Thank you very much. And I think this is a very good starting point for a lot of companies going into the robotics direction. And I just started to text a little bit as I'm also getting the information from the AFR. And when we look to what we have here in the US, at the moment, on average, the US is around about 228 robots per 10,000 employees. That is a national average. So there are other countries like Singapore, they are more than above 900. That is where we are. So we at BMW see that in daily life when we look for experts and for partners, not just here in the Upstate or in South Carolina, all across the country. And I think it was mentioned a couple of times ago that this lack of skill is also related more or less to this lower number of installation. And with giving smaller businesses a chance to really start this, I call it a journey, because it's like it was rightly said, it's a starting point to bring that up. And here those are very good solutions, which gives them a chance to come to this level, and then step by step start to grow. From the BMW side, as we have large installations, our requirements are certainly different, for sure, but it would at least give some of our partners we have here a fair chance. Because we have our own training centers, we have our own specialists, and more or less we have our own software, which is pretty similar to what we have just seen on the screen. So in our standard, we can connect 3 manufacturers, KUKA, FENUC, and ABB, with more or less a plug and play scenario as well. But that is a similar concept, just on a larger scale. And here I would highly recommend actually, to go further with that and introduce it into the market.
I'm gonna go off script a little bit and go to Matthew Cave with Michelin. Matthew, given your expertise in strategic marketing, you hear numbers like 228 or 288 maybe robots per X employees versus competitive markets at 900 or much higher penetration. And yet, guys like John McDonough might feel threatened from his constituents that this might represent a loss of jobs. So, how do you think about the progression around competitive positioning and maintaining your competitive edge with the fear that could come from change. I'd like to get your thoughts on that macro theme.
Certainly, I think it's a great question. I love the thought around the fact that skilled labor is honestly our biggest challenge, right? I mean, 100% what we face today is kind of that seeking of the highly skilled talent and the ability to be able to seek those folks out. And I think what Kel has been able to show us today is really kind of a bridge that can help us to be able to seek out the people that we currently have in our factories and be able to train them up to that. And when it comes to the competitiveness, that is a real threat and one that we deal with every day. There are a lot of imports of like products that are coming in today. And what we struggle to be able to do is build the same quality of product with an automated system. To be quite honest, when our product is a little bit fluid, right? Rubber is not something that it's not like a stamped product that you have in a body shop that is more or less the same every day. Rubber tends to change over time based on humidity and things like that. So one of the things we've struggled with is the ability to really be able to train automation to be able to adjust to those small variations in product as they come about. And I think we need to be able to get to that place. And part of that is by making the system easier to understand by, the average citizen in the US to be able to understand how to manipulate that software to be able to make up for those minor variations. Today, it requires a very high level of skill to be able to do that. And I think advancements like this that Kel was able to show us is a way that we can make that plain and everybody can be able to understand. So it's really an exciting kind of concept there.
Let me bridge on that concept of around quality and automation. Mike McCormick with Bosch Rexroth, Elon Musk will openly admit that he went too far initially with his efforts around automation, and he observed famously that humans are actually pretty good robots, and so. So I'd like your observation on the importance of these transitions around simplification and to solve this problem around labor gap, juxtaposed against the quality and change risk that comes with that. Talk about that tension.
That's a lot in one question, but I'll do my best.
You got all that experience.
I think the one point that after watching the demo and listening to some of the panelists, in many industries like our own, we have a highly labor-intensive product with opportunities for automation. So automatically, you're talking about mixing people and robots in a close proximity. And earlier, 1-2 decades ago, every robot was behind a fence, which was behind a security rail, which was behind light curtains. There was no way to mix people and robots. Now, with the evolution of cobots, collaborative robots, you can actually have workers side by side with robots without a fence, without light curtains. That really has opened up the number of applications and the ability, for example, in, let's say, a high mix, low volume production like ours, we can start now using more and more automation because the robots are right there side by side with high skilled technicians. And as you said, there's some tasks it's much better done by a human, but very next task, you need a robot or you should use a robot. So this really was a game changer in robotics, the introduction of collaborative robots. And I think coming to your other point about the quality implications, I think there's no doubt that automation automatically brings with it a high process capability. And that is something that all customers expect now. Uh-huh. They are so accustomed to having Amazon bring the right box on the right day to their door with exactly what the expectations are becoming higher and higher for perfection. And really, unfortunately, we as humans, myself included, we're not going to achieve perfection. And that's where really automation, whether it's a life safety issue or just a customer satisfaction issue, automation, including robotics and other technologies, is the only way forward. And maybe one last comment to Mr. Musk, because he uses a lot of our automation Shameless plug for Bosch Rexroth. But I think he did learn an important lesson. You're replacing, let's say, semi-skilled workers, but at the same time, you're increasing dramatically the demand for very highly trained technicians. And I think the other panels have spoken to that. But many companies don't do the math correctly. They just assume all the cost disappears.
Right.
And nothing else is needed. But clearly, the infrastructure to maintain automation must be considered in the business calculation. Excellent.
Very well said. Brett, I'd like to go back to the demo. Given your experience in long history in implementing automation solutions, over the course of that period of time, I'm curious what your thoughts were watching the demo. Did you feel like, wow, things have changed so much over the years, or it's another step forward? I just would love to get inside your head in terms of what your thoughts were as you observed that prototype.
Sure. I think for me, when I think about the way that we're utilizing automated solutions today and the ones that we have planned for the future, we have to be very careful about which part of the world that we're going to implement those solutions in, because to everyone's, the theme here is that you can build the most incredible solution in the lab, and then when you go put it onto the shop floor and you move on to the next project, that has to be maintained and nurtured. And so, seeing what I saw today and when I think about the opportunity to teach a broader group of people faster to be able to, maintain that new industrial solution, it certainly gets me to thinking, because being very candid, I have to say that as many successful automation programs I or my team have overseen, there's maybe not equal, but there's also a number that have been industrialized and put into, the manufacturing shop floor that ended up as dust collectors, because there simply wasn't anyone there to maintain. And a lot of the maintenance technicians and manufacturing engineers that are coming from our universities could certainly benefit, much like some of the basic engineering training that was offered a few years ago, just a couple years ago when I was in school. The ability to touch this many different robot solutions, this many different OEMs with one stop is certainly powerful.
That's really compelling enough to go off script here and invite Marty Osborne into the discussion. Marty, given your expertise in maintenance and hearing the observations from Brett around the importance of maintenance and operating and maintaining this new infrastructure, how do you think about maintenance and operations, how it needs to evolve and change to ensure greater success in this environment of increased automation, especially around robotics?
Yeah, I think it's a great point. And I think, with Brett and Mike bringing it up, what we're seeing out there with our clients, right, is that transformation from the old maintenance school used to be, the guy who would work on his cars and fix stuff and could take a motor apart, when in actuality, the future of automation is totally changing the way you maintain it. And I think that's what gets us back almost to the educational system. We're starting to see more and more clients, instead of the traditional maintenance tech, starting to bring more electrical automation guys into the maintenance world. Because the one thing I, look at is just, you mentioned the thing, like, I think when a tap's broke, like, those are things that are going to go on every day. And how are the maintenance teams getting notified? How quickly can we turn, that repair around? And also, how quickly can we get the part if it breaks? So yeah, automation brings a lot of new complexities to the maintenance world in terms of uptime and the skill levels.
Dr. Keith Miller, you're president of Greenville Tech. You have been hearing these issues and these themes around not enough workers, the skilled talent gap, the regional, national, international importance of this competitively. What you've seen today, what do you think about this thesis of using technology to help bridge that gap and to simplify that that interface to facilitate greater adoption. It's an idea that's been around for a while. Do you believe it? Is it something that you think can really help move the needle here?
I think it certainly can, but there's actually, in terms of more turning out more technicians, to put it crudely, there's actually a larger challenge than what you had indicated. But before I address that, a lot of the things that we just heard is the reason that Greenville Tech built the Center for Manufacturing Innovation. Matter of fact, some of the robots that were named, some of the companies that build robots that were named in the demonstration, we have those same companies put robots in our Center for Manufacturing Innovation, and they use that as a demonstration site for their customers, as well as training for our students. So they get firsthand training on the latest and greatest, you might say. And we turn out, if I focus just on robotics and mechatronics, which is of course the servicing and maintenance of robotics. If I focus just on those programs, we turn out probably 400 technicians a year, and that's not near enough. I'm hearing from companies like BMW, like Bosch and Michelin and others. That's not enough. So what is the challenge? Because we have the capacity to train more. We have the capacity to actually triple that. The capacity is getting them in the front door, meaning that younger learner or that individual that's been out in the workforce for many years and wants to change careers. First of all, on the younger worker, we do a lot with the K-12 system, and a lot of our employer partners like Bosch and BMW, Michelin, and others do a lot with us to try and encourage the 17, 18, 19-year-old to go into manufacturing as a career. But I will tell you, it's an uphill battle. And part of it is simply due to history. Manufacturing hasn't always been the high-tech environment of robotics and everything. And our students, or our K-12 students, know that history. And they're not always understanding exactly what manufacturing is about. I had some K-12 advisors tell me that the challenge of convincing the young adult, again, 17, 18, 19-year-old, isn't so much with them as opposed to their parents and grandparents. And I asked what he meant by that. And he said, for a lot of these kids, he said their parents and their grandparents grew up in the textile industry many, many years ago. So to them, that's manufacturing. And that's the mindset that we are about changing. And so that's a constant struggle that we have. I think we're making inroads, but a lot more needs to be done. And then when I look at the older adults, somebody that's been out of high school for 20 or 30 years, and bringing them back into a higher education setting, the challenge we face there is simply lack of basic skills, as in math especially, and mechatronics and robotics as programs are heavily based on math. But we've restructured how we address that too, to make that a little bit easier for those individuals to get back into education. We have over 760 advisory board members from all types of business and industry. The role of those advisory board members are to help our faculty keep curriculum up to speed, and that's very workable. And I think we need to actually even strengthen that even a little bit more. And I think the approach to bring in that young adult from high school, the partnerships that we have with industry are extremely beneficial. And there's a big difference if a 17-year-old hears from a recruiter from the college about manufacturing as opposed to somebody from one of the industries talking to them about all the job opportunities in manufacturing. That's much more effective, much more effective.
Well, hopefully this forum is will move us forward in that regard to the younger audience attendees. There's great opportunity here, as you've just heard, but it's tempting to underestimate the cultural and societal influences here, and I appreciate you highlighting that. I think that's there is truth there, Dr. Miller. Thank you, Mark Johnson. I think what it's attracted me about your introduction is this theme around application and scale and making things happen. Not being the number one serial number, but number 1,000. And so, first, I'd love to hear your thoughts on what you've seen, and then secondly, I'd love to hear your observations on what you've been able to do to help accelerate adoption and embrace, accelerated automation environments.
Thank you very much. I appreciate it. And what I've seen, first of all, Kel and Ben, great job in terms of the demonstration. My guess, if we asked your staff what you do, they would say, we do robotics. So there's a discussion of, well, how do we make manufacturing cool again? I would almost argue with people and say, why do we need to even try that? Just tell people they're doing robotics and let the Bureau of Statistics track it all, or tell them they're all doing big data analytics or 3D printing. And you've got a ton of people coming into this field right now in that area, especially sort of the underage 25 people that are coming in. And a huge resource on this is the number of people that have, probably been deployed at least once elsewhere before they ever went back to college. And they were in charge of $50 million pieces of equipment without a lot of oversight, a lot of evidence where the stakes were high. These are exactly the people you want to wind up hiring. So there's a huge opportunity on that. And so I think there's an element of let's just embrace the future and go forward. Greenville does that. So I'm gonna take a step back to the second part of your question first, Alex, on this, which is, where does manufacturing stand? I'm not saying that manufacturing is not important. I'm just saying the imagery of it isn't necessarily, we don't have to win that one to win the war on this. The U.S. manufacturing sector, when people start saying, oh, we can't make things anymore, that's just grandstanding without any evidence or data. The U.S. manufacturing sector is a $2.5 trillion sector. There are only 6 countries in the world at which their entire GDP is more than $2.5 trillion. Right? So we're really talking about China, Germany, South Korea, Japan as our real rivals in this at all. And frankly, we're at about the same GDP per capita ratio with Japan and Germany and South Korea as we were 3 decades ago. So it's the rise of China that is the competitive part. Then you look at what's going on in Greenville and in South Carolina. We're number 10 in automotive manufacturing as a state. We're number 2 in automotive exports. What that means is that BMW and Volvo and all these companies that are building automotive plants here are not coming here to have lowest labor cost relative to Detroit. What they're doing is coming here so they can sell those 70% of the cars that are exported out of the country. The way you do that is with advanced innovation and advanced technology. What it's an admission is this is a place that's actually willing to embrace that. And just a piece of evidence relative to that, if you would come here 40 years ago, the tagline of Greenville was we're the textile capital of the world. If you go to Youngstown, Ohio, they still think they're a steel industry town. And they knocked down their last blast furnace 40 years ago. What Greenville's about is change and being able to accomplish that change. So what does Clemson do in regard to this? And it's not that talent isn't important. We actually recognize talent is important. So we've got, well regarded at ICAR, the automotive engineering. I'll point out that you've got companies like Rivian and Tesla that are competing for those students coming out of here. So we've got internationally recognized talent coming out of here right now. So that's a challenge. We're kind of doing our job, Keith, together right on this, and that it means that the companies here have to compete with companies around the world because they recognize the importance of what's going on here. Other program, and this is the One Research Drive building behind me, is developing a BS-MS program so people in 5 years can wind up getting a computer science degree. Because if you talk to a lot of manufacturers, they say, yeah, we need industrial engineers and mechanical engineers, all this. But what they really need to know how to do is program and how to do data analytics, and they need to do all these sort of other things. That's a computer scientist as well. So having that sort of skill set, it's not the same engineer that you need as a degree in even 20 years ago or 30 years ago when I went to school. It's a new skill set. So then how do we also use that technology? And one last thing here before I hand it off. And we work a lot with the community college system in our Center for Workforce Development in terms of training and skill sets in deploying augmented reality in training and developing that new field, so that you have someone that has that sort of generalized knowledge on how to work in a mechatronic environment, but they may not know how to work with this specific piece of equipment or this specific context of it. If they can wear augmented reality, walk out on the floor, it pops up right in front of their face. Here's what you need. Here's how you do it. It gives them the answers. That greatly increases uptime. It increases the capacity of those people. And that's what we need to wind up doing. We need to keep pushing forward in that area. I will say to everyone in the next community here, there's a huge number of startup opportunities in this area. It's a target-rich environment for opportunity. So that Greenville's in a great place for this.
I agree, both on Greenville and the opportunities, and and on the challenges of attracting this next demographic towards this career. I think that there's to Dr. Miller's earlier point, there might be some optical challenges with the term manufacturing, when that's really not what we're not dealing with the same manufacturing we were 23 years ago. So David.
Hey, Alex, relative to that, also just one follow-up. Sorry about this. If you look at, I do some work with the German and Japanese governments on this, and the U.S. to a certain extent, we've got an aging population. That's a good thing. People are living longer. People are staying in school longer. Don't have more robotics, we're not going to be able to afford we need that as a productivity, as a foundation for our economy. If you look at Japan and Germany, they're running into a demographic, headwind. They're not going to be able to afford their social security system if they don't have robotics. So this idea of, is a robot going to take my job? It's more like, is the robot going to pay for grandma's social security is the issue. And so, I think that's a different perspective on that there's an imperative to have robotics.
David Broomer, do you share that view? I'd love to get your thoughts on that.
Yeah, well, I very much do, actually. In fact, we're working directly with Mark Johnson on a variety of projects. So we think very much eye to eye. A couple of interesting thoughts. So I've been a huge advocate for many years of getting the right human-machine interaction metaphor. So you can look at Windows as an example, and I think certainly this is what Ready Robotics is trying to do by creating not only an operating system, but good graphical interface tools. So often in the past, looking at a few different examples, when you get that interaction metaphor right, your skill gap goes away sort of somewhat magically, because all of a sudden you've reduced all the complexity. And what a metaphor does is it names and frames the problem in a new way, right? So Windows, in other words, organizing a file system based spatially is an example of that. But there are many others. The joystick itself, which we now take for granted, was an example. One example that I love is, I led for many years autonomous landmine detection and robotics efforts for the military. And one of the things that we found was that there was this huge push to make everything, quote, fully autonomous, which is what, the warfighters and the decision makers really believed. And for a time we did that. So we moved the detection rates from 80% to 92%. And a lot of the defense contractors then wanted to declare success. But what we found was that if we use the human insight, especially for the anomalies, we could get that detection rate up to 99%. Which is a big difference if you're the guy in the minefield, right? It didn't sound as good on paper or in PowerPoint presentations, but boy, it was a massive difference. And once the war kind of switched from traditional landmines to IEDs, in other words, improvised explosive devices, skilled humans could sort of be what we like to call like a phone a friend for the autonomy, right? So the autonomous robot could essentially call a human expert who would say, oh yeah, no, that's a Coke bottle that's been cut in half and filled with explosives. I've seen that before. Right. So I think across the board, what we really need is to stop talking about full autonomy as if it's sort of the panacea and the right solution to everything, but rather talk about crafting these sort of context sensitive teaming relationships. And some of the panelists were talking about cobots. That's really important. I love the example of one of my friends and colleagues who helped with the Kiva Robotics, really put the Kiva Robotics deal in place with Jeff Bezos. And at the time, of course, they were selling that as we're going to get rid of humans by having these robots. That's not actually what happened. So in practice, what it did was it didn't get rid of a single Amazon employee, but it dramatically changed the scalability, right, of the Amazon distribution system. So I think that's a good example. And to use another example for the actual use of thousands of robots in our work with the military that started with our work at DARPA, it was sold to Congress, right, that we would actually get rid of, you can look this up, it's a matter of public record, that we would actually get rid of half of our human workforce. In other words, we would get rid of a lot of soldiers. And that also didn't happen, but we did save many, many, many lives, right? Because we kept humans ultimately out of minefields, and every one of those robots that got destroyed was a human that wasn't. So I think what we need to understand is that when we do robotics right, we don't eliminate the human. Calculators didn't get rid of mathematicians; it expanded the reach of math, right? And I think that's a simple example, but the honest truth is that once we get these what I call interaction metaphors correct, it really changes the landscape. And so maybe that's again more of a far-reaching, almost like philosophical goal here, is that with manufacturing, we need to present some new metaphors. We need to change the interaction scheme. That's certainly what Ready Robotics is doing, and I really applaud that effort. But there's more that can be done. And what we ultimately need to do is we need to make these robots fun. We need to make them exciting. Kids already find robots exciting, but we need to actually make this not about inverse kinematics so much as we make it about creativity and problem solving. And I think that's really the key. I think one way to do that from a practical perspective is to change the kind of educational paradigm, to do less and less in a traditional classroom environment and more in what I would like to call like an intimate, artisanal craftsmanship, right? Where we sort of embed students into workplaces and we sort of enjoin them to take part in the chaos that is a real business environment, right? So those are just some of my thoughts, but I do think that the demo was really impressive. I think it, as a small sort of side note that may be interesting to you, Kel, when I was at DARPA and we did the initial software for distributed robotics program and the MARS program, which was mobile autonomous robot software, the proposals that we received in 1999 from all these different big institutions really had your software in mind, right? So I think it's so interesting that it's literally at this point, I suppose, 22 years later, that we actually have a practical demonstration of what DARPA was asking for at the end of 1998. So good job, right? I think that's a telling sort of, and I mean that in a very positive light, right? I think by the way, literally the DARPA work was supposed to be at a 25-year horizon. So actually, I suppose you're ahead of schedule in that regard. But I really do think that ultimately what I am excited about personally when I see that kind of demo is not only the progress we've made, which is considerable, but also how that can be used as a platform technology for the kind of creativity and problem solving that is ultimately the human's, most salient feature.
I want to go to Bob Little, but before I do that, I'll jump to Dr. Baginski on the observation around not being a threat to the employee, even if it's promised in the case of the military, but actually being a way to super empower, to superpower the potential and ability of each employee. Dr. Baginski, your experiences at BMW in this context?
Yeah, I think I dropped a little bit of text also. So, and whenever we talk about automation and robotics, and we discuss with the government, with us, we always try to make clear that we have this kind of setup, not to replace the worker. So this is actually to give us the chance to produce things, to make things which we would not be able to do without the automation. So meanwhile, the modern automobile has a lot of materials you can't process any longer with a manual process. That's not feasible. And the complexity of the products we have, this is also not achievable. In our main lines, we are capable of producing 5 different kind of models on one line. And we have roundabout to move 6 million parts here on site every day to give the customer in the end the freedom of choice, what they want to have. So to do those things, we have to use, let me say, techniques like having a complete digital twin of all my production lines in the cloud. And this cloud steers all the production lines. Those kind of things. And all that is in the end so that we can achieve a one-piece flow so that you can choose whatever you want when you come to the dealer. And those kind of things, they drive our business in here. And to do that, in a lot of cases, you need automation to robotics, because for just a manual worker, this would not be achievable any longer. And that was always our plan when we grew with our automation, to make us better and actually to give us a chance within a time frame of more or less 14 years to double up our global volume. This would not be feasible if you would go the traditional way. And this is exactly also what we did in China. So when you walk into our doors here in South Carolina, you will see exactly or nearly exactly the same installation in China. So it was never about the workers' cost there, because everybody knows that those are rising as well, heavily. But to have the same product and the same quality, this is really essential for us. And those are things, those are big elements of a communication to say, hey, we do this to be up front of everybody else in here, not to place and have less workers.
Exactly. Well stated. Bob Little, we've heard now, we've gone around the bend, we've heard from everybody, and your starting observations around the importance of simplification to facilitate the embrace of this automated environment. It seems even more profound now than it did 30 minutes ago. I have a feeling you have some color to add, particularly around these themes of complexity and social issues that might prevent greater adoption. Love to get more of your comments, Bob Little.
Yes, and first of all, I heard some very fantastic positions here that fit exactly the way I see things as well. At ATI, we're spending literally millions of dollars to create new product that's easier to use. Every aspect of our work these days is to make a product that can come out of the box, mount to the robot, and be usable in a very short amount of time, and that the operator then finds it easy to use. There is a lot of jobs out there that people struggle with by hand. Welding is an obvious one that we've tackled over the last several decades very successfully. But there's a lot of jobs like sanding and grinding, for example, that are just back-breaking work. And as robots move into those type of jobs, the products that have to be developed cannot be too complex. They have to be simplified and make it easier for the operators to use them. Because I was looking at an article just yesterday, and it was about deburring some automotive parts. And what this end user did was he took the operators that were doing the hand deburring. He had software created in the new robotic system that he purchased. And now the same people who were hand deburring run the deburring machines. but they had to simplify the software to allow that. That's what Ready is doing, is they're creating these systems so we can take people who are doing the manual labor and making it easier for them to actually operate the system. And that, when done correctly, is going to be a massive breakthrough that'll allow the robot market and the manufacturing market to grow exponentially.
Ben Gibbs is the CEO of Ready Robotics, and Ben, first of all, congratulations on all the praise you've gotten on that brief demo. It looks like it hit the bullseye, and we've heard this theme around complexity, the need to simplify. Talk about the future of Ready Robotics in the context of what you've heard today.
Yeah, so for us, it really is about working with companies like ATI and Shunk and others to pull together everything and enable them, as Bob was alluding to help create these type of easy to use applications and tools that can very quickly spread to the rest of the industry. We have a very exciting announcement coming in April about the next version of our software that is angled towards this type of enablement. So when Bob's company, for example, creates a new piece of software, or anyone really does, it can much more effectively scale up to the rest of the industry, because today, because of that fragmentation problem, that's very hard to do. In the PC world, when you create a piece of software, you hit a button and it's going to just run on any computer that is running Windows. In robotics today, you have to go OEM by OEM and do some very complicated integration work to solve that. And that's ultimately what we are on a mission to do, is to enable the builders, the creators, the developers to create new, interesting solutions that probably none of us on this call have ever even dreamed of, using robotics and using automation and all the other cool tools and devices out there to make lives better and easier for everyone. So that's what we're on, and that's what's coming next for us, is really enabling that developer community.
That enablement is, it's clear there's a lot of both latent and expressed demand for that. Milton, I'd like to bring it to you. We've covered a fascinating range of topics around global competitiveness, around social and cultural challenges, around a history of transition and automation. What have we not covered today that you think that you would add to the mix?
Alex, you're exactly right. There's so much covered. I was thinking about where we've been, and I want to back up just for 1 second and start where we started. We started talking about how many robots are operating in the country per 10,000 workers, and it's 228, and that's number 9th in the world. We moved on to competitiveness, and we think about that. You know, we heard of competitiveness for small to medium-sized enterprises. They make up 98% of all manufacturers. So 98% of all manufacturers are under 500 employees. But it doesn't stop there. You know, Mike brought up something that was really pretty amazing, that he sees the ability to get into other applications that were once shut out because of whatever complexity and things like that. So let's look at what we really saw today. And I think that's something that we want to make sure we cover. We saw really glitzy software, and it was very cool and very easy. But what we really saw running in the background was an ecosystem. These guys have created an ecosystem that allows that software to do what it does. And it brings in companies like Shunk and ATI and these other components. And that's where we get to what David was saying, because now the operator or the person putting this thing and deploying it or redeploying it, let's think about that with automation, going back to what Mike said, talk about the complexity. Deploying robots is one thing, but if we want them to be in high mix, low volume applications, redeployment is very, very important. So this ecosystem had a gripper in it. It had tapping machine. It had force control. It had all these things that allowed that person, getting back to what David said, to be very creative. So, you know, that creativity is bringing the person who understands that product and that process, it's bringing them to the forefront. And that's where I want to make sure we don't forget something. Robots don't take jobs. They actually create jobs through competitiveness. They absolutely do. OECD says that companies that deploy technology at a high rate are 10 times more successful than companies that don't. So we let that sink in. We know that we can help these small to medium-sized enterprises. We can help these complex applications if we can create these ecosystems that allow the creativity to come to the forefront. And I want to leave it with one thing. I really, enough people through the door coming out from, Greenville Tech. That's an interesting thing. How can we make it cool? And even if cool is the word anymore. Yeah. So I don't know that I'm the right person for that, being also so many years in the industry, but we have to excite people. And I like, whether it's robotics or whatever the words are, we have to find out what's exciting them, but we have to get more people through the door because this means something. And having enough of these people with this creativity really means something.
I think one thing that could move us forward on the cool factor is to let everybody have a bookshelf like Ben Gibbs. The Star Wars theme might attract the demographic even better. Mike McCormick, yes. What's striking to me is there's so much great evidence Milton just laid out around how important this is to our competitiveness and to efficiency and productivity, and yet when you invest in companies like these, you're always worried about sales cycles. It takes so long for deals to close. It's a really long sales cycle. What can be done to either, or is it a false premise, or what could be done to accelerate adoption? If it's so good for everybody and it's so important for our competitiveness, why isn't the ingestion of new automation and technologies happening faster?
First of all, let me touch on the first point you made, business cycles. They are more frequent and more extreme than ever. Yeah. So this to me is already one mega trend, which on the one hand makes jobs like mine extremely interesting, sure. Yeah. But also I think drives the subject of automation more and more, because right now I'm in the middle of a hiring blitz. I can't hire and train people fast enough. The COVID downturn was brutal, but short. And now we're trying to ramp back up to full power. So automation absolutely plays a role in that. And there's one other point I want to bring in, and you asked the question of Milton, and I think Milton touched on it a bit. The next topic, which we really didn't have time to touch, and maybe it could be the theme for your next webinar, is the whole data ecosystem behind automation. Manufacturing is a data-intensive business. And while you automate the physical work, there also has to be an equal amount of effort put into automating the data management, extracting out the business vital information. But also, this data can provide new business models, new ways to grow. Yeah. And I think the whole subject of Industry 4.0 expanded really into the digitalization of manufacturing now. I think we're moving on to a new buzzword, digitalization of manufacturing. I think for me, that is also, let's say, the partner to robotics that we have to also keep in perspective.
Mark Johnson, it looks like you may have a comment.
Yeah, I'm glad, Mike, you brought that up, the whole digitalization, because then the other thing in this is worth a future conversation as well, is that opens up immediately to national security assets. It's literally about protecting machine tools and robots in shops. And there's a training element of that. I will point out that Clemson and actually the South Carolina Technical Colleges, in partnership with us, we're part of something called CyMani, the Cybersecurity for Manufacturing Innovation Institute, that was set up last year. It's a nationwide institute looking at cybersecurity around manufacturing, and it's a training problem as much as anything. And just to give an example, there was a study done said if you want to own a company by cybersecurity, you get a bunch of flash drives and you write 2022 executive compensation schedule all over them, and you scatter them around the parking lots where the executives park, and you'll own that company by lunchtime, because everyone will take them in and they'll put, it's that kind of training. But 80% of these things are human. The humans become even more important because they're human vectors are to the interface to it. So all of that becomes, it's we need the technology. We also, it opens up new opportunities in there, and there's interest for students and workers and all that sort of stuff on
it. Marty, what do you think about the connection of this idea around the business opportunity on the digitalization data management side?
Sorry, it was funny. I was just typing in, I'm kind of intrigued, like the whole digital twin aspect that I think was brought up, right? Because one of the things we found, even from a maintenance standpoint, right, is do we have the skills to actually go out and fix something, but through digital twins, through kind of remote monitoring, we now can bring experts in remotely. You could tap into like ATI experts. If you had a robotic problem, you can see it. So yeah, I think the digitization, digital twin, where I can start to test things, try things, is going to be big. And it's funny, I just kind of pinged Kel because I'm kind of curious more about the data coming out, right? Knowing number of cycles to instead of doing maintenance on a calendar or a time basis, it's all based on utilizations, based on numbers, based on what the equipment is telling us. So I see in our world that maintenance is changing because we got to start listening to our assets, not just trying to try to tell them what to do. So lots going on there.
This is the fastest hour and a half in America right now, so we only have time for two more comments. I'd like to offer some closing thoughts from Matthew Cave at Michelin. Matthew, what are your general takeaways or observations or key points from today?
So thanks for the time. I think what's exciting, and we've talked a lot about the competitiveness and the things that are up against us, but I think what we can see is that the state of South Carolina and this region has continually, over the course of the last 100 years, evolved at a very fast rate. And I love to see the fact that helping to lead the way and bring manufacturing and the transformation of manufacturing, with all of the resources that exist from Greenville Tech to Clemson, and all of the other partnerships that are around, helping us to be prepared for the future and really put us in a position to be able to compete globally. Because one of the things that here in the Upstate we're doing is we are really competing with exporting goods as much as importing goods, right? So we build a lot of our products that we're shipping out for the rest of the world. I know that BMW down the street's doing the same thing. So we are really on a global playing field here. And the ability for us to lead the way and be able to automate some of our things and produce at a higher rate will lead us to be more competitive from a cost standpoint, quality standpoint, and really lead us in the future.
Last but not least, I'm sorry I didn't get to everybody twice. Again, the fastest 90 minutes in America. Kel, you started this, you kicked this off. You've heard a lot of roundtable discussion. I'm curious what your takeaways from today's discussion have been.
Well, I really like the trend that we're all thinking about in that bringing manufacturing more to a general awareness, right? And I think that as the technology gets easier, as we start building platforms on top of that technology that sort of make it more consistent, we'll see that people get invested and excited about it. Not just us who are very much, already embedded in it, but the rest of the world. I mean, it's very similar to, nobody was thinking about how exciting it would be to build an app for a phone in 2003, right? But as soon as you had, widespread technology, as soon as that technology was accessible, you had developer ecosystems created on top of that technology. Now, millions of people make apps for phones. And I see a vision 10 years from now where millions of people are going to be building technology for manufacturing and solving as Ben said, the problems that we don't even know exist yet, and building solutions that we haven't thought of yet. And I think that ubiquity is going to come from all of the individual pieces that we've been talking about today, the technology, education, partnerships, and everything together. So I love the direction that we're moving.
Excellent. And that's a great note to close on. If you'd like to know more about Ready Robotics, reach out to Kel or Ben directly or via the chat function. The same for Bob Little at ATI, directly or through the chat function, and Milton, the same. So I'm very thankful to Milton Geary, Bob Little, and Kel Giron and Ben Gibbs for their efforts to help lead this discussion. I am so impressed by the thought leadership of this group. I think it's just it's world class, and it was really, really insightful and helpful. Hopefully, it helped the audience. And thank you again. To me, the takeaways from today are one, we are a build country and a build region, and manufacturing has kind of been a weird word for the last 30 years, but it is undergoing a dramatic transition right now through all these developments in automation and the shrinking of the business cycles, as you've just heard. It's a huge opportunity for not just businesses and entrepreneurs, but for kids out of college and those with STEM backgrounds in their education. So, and finally, and most importantly, I think that the Upstate has a once in a decade, once in a century type opportunity to lead here again in terms of leadership around embracing this automation. So thank you to this esteemed group of expert panels and to our panel, our demonstration team. Thank you, and look forward to seeing you all again soon.